Hi friends, very good morning. It is our second class on the 10th NCRT, chapter 3, moving charges and magnetism. In the last class, we discussed what? We discussed how this current carrying conductor generates magnetism around it. Okay, when current flows through a conductor, made straight conductor or a solenoid, if current is flowing through a conductor, then magnetic field lines are generated around it. Okay, so suppose if it is north south, then generate from north to south. Okay, so in this class we are discussing whether the reverse is possible, that is whether we can generate electricity from what? From magnetism. Okay, so that we are going to discuss in this class. For that, first we are going to do an experiment. So we can do an experiment. For to do this experiment, we have a solenoid and a galvanometer. A galvanometer we have. Then we have what? Simply a bar magnet, north to south. North south. We know that a magnet has two poles. And one more thing, magnetic monopoles, it never exists. Okay, that is we can't isolate north pole, south pole. Everywhere we have magnet, it is dipole basically. Okay, so we couldn't isolate them, or magnetic monopoles do not exist. Okay, so it's for your knowledge, basic knowledge. Okay, so now we are going to do this experiment. So this is a solenoid, and I have what? I have this galvanometer with me. So we connected this galvanometer. So what's the purpose of connecting this galvanometer in this circuit? Oh, for what we are using this galvanometer? So galvanometer, it's an instrument. It contains a needle, and this needle deflects if current is present in a circuit. So galvanometer, it is used to inspect the presence of current. Suppose the current is flowing in this direction, then galvanometer needle deflects in this way. Suppose the current flows in this direction, so it deflects into this direction. So basically it is used to detect the presence of current. Okay, so we connected galvanometer to this solenoid. Well, then we have a bar magnet with this one. Okay, now south. Then what we are doing? First of all, we are inserting this bar magnet into this solenoid. So while we are inserting it, we could see that the galvanometer needle deflects into this direction. It means current flows in this direction. Okay. Then what we did? Then what we did? We just inserted this magnet into the solenoid and keep it as such. Then we could notice that now the galvanometer needle, it's in this way, no deflection. So the current disappears. Okay. So why it's so? At that moment, we just took that magnet outside, just outside, in this way. At that moment, this galvanometer needle deflects in this direction. So current flows in this direction. Okay. So initially, when we inserted that magnet, that is, when we inserted it in this way, magnet, when we inserted it, this galvanometer needle deflects in this way. So current flows in this direction. So after that, we put it inside and keep it as such. Now there is no deflection in this galvanometer. That is no current in it. Okay. Then after that, we just took that magnet outside the solenoid. Then what happens? Then the galvanometer needle deflects but in opposite direction. Okay. So what's really happening here? We know that when we inserted the magnet, current is generated. Okay. Then after that, we took it outside. Then also current is generated but in opposite direction. Okay. But when we kept this magnet inside the solenoid, then what happens? Then current disappears. Okay. So we have to analyze all these observations to conclude what's really happening. So what really happens to this magnet when we insert it to this solenoid, and what happens when we are taking it outside, so that this current is generated in both cases. Okay. So just analyze. We have this magnet. It has two poles, north, south. And we know that we have this magnetic field lines around it. So magnetic field lines, it always originate from where? From the north pole and ends at south pole. Remember. And they never intersect. Okay. Then these are the magnetic field lines. So we can mark it in this way. North to south. Okay. Then everywhere it is as such, north to south. So I'm drawing an enlarged view of this. So this is our solenoid. When we are inserting this bar magnet, this is the bar magnet we have. Okay. So when we are inserting this magnet to this solenoid, which is connected to this galvanometer, this field lines around it, it is getting cut. Okay. It just cut. And when we are taking this bar magnet, outside, then also this field lines are going to cut. So basically when we are inserting this magnet as well as taking it out, this field lines linked with that magnet, it is changing. Okay. This field lines, it gets changed. Okay. So whenever there is a change in field lines, current is generated. Okay. So any variation in this field lines lead to the generation of current. So from this class, we could realize what? We could realize that this magnetism, it can generate electricity. And in the last class, what we had learned? We learned that electricity itself can generate magnetism. So these two phenomena are interrelated. Okay. In the coming classes, we are going to discuss the working of electric motor and electric generator. Electric motor and simply generator. So how a motor works, how a generator works. Basically we know what? We know that in motor we are providing mechanical energy. No, we are providing what? Not mechanical energy. We are providing electrical energy. So in electric motor, we are providing electrical energy. So that is the input we have. Input we are providing, and motor, what's happening, the mechanical energy it's generated. Okay, mechanical energy it's generated here. This is, so mechanical energy we get it as output. So generally the principle by which this electric motor works, that we call motor principle. So in the coming classes we discuss first motor principle, then the working of electric motor. So similar to electric motor, electrical energy to mechanical energy conversion. Electrical energy to mechanical energy conversion that we can observe in our electric fan, refrigerator, grinder, mixie. In every such instruments we can observe this. And the reverse phenomena that we can see in generator. Generator, from the name itself we get electricity, that is electricity is generating here. Okay, so we are providing what? We are providing mechanical energy here to work. So this is the input, and output is electrical energy. Okay, electrical energy. Moving coil, microphone, moving coil microphone works based on this way. This mechanical energy to electrical energy conversion. And another instrument that we will learn in the coming class, that is moving coil loudspeaker. Okay, that works on the basis of motor principle. So simply what we had learned today, we are going to consolidate. We learned this, how this electricity that is induced in a circuit whenever there is a change in flux. This magnetic field lines together we call it, suppose if it is north and south pole together, this magnetic field lines, we call it what? We call them flux. Okay, magnetic flux we call them. And whenever there is a change of flux, it leads to what? It leads to the generation of, or the induction of electricity, generation of current we can observe. So magnetism, how magnetism leads to electricity, that we had discussed in this class, and that's the main thing we discussed. And in the coming classes we are going to discuss how an motor works and generator works. So simply, in motor, electrical energy that is converted to work mechanical energy, and in generator, this mechanical energy that is converted to electrical energy. That is electrical energy that is generated here in the generator. And in the case of motor, electrical energy is converted to mechanical energy. Okay, so that's all about today's class. So if you really likes the class, please subscribe, and just mark your attendance by pressing the like button. Thank you so much.